Okay. All right. Welcome on in, right? So this is a maths paper 1 question paper. This was the paper that was written grade 8 term 4 examination. It was the November 2024 paper. It was written here in the Eastern Cape specifically, right? So yeah, with this paper, all right, the time 1 hour 30 minutes as expected, of course. All right, with a grade 8 paper. Let me just remove this little icon here, this little sticker. Okay, all right. So as you can see here, it says 1. The question paper consists of 5 questions. Answer all the questions. Show all calculations and steps clearly. Calculators may be used unless stated otherwise. If necessary, round off to 2 decimal places. Very important instruction here that if necessary, you need to round off to 2 decimal places unless it's stated otherwise. Then 6, answer the questions on the question paper. And then 7, write neatly and legibly. Okay. So this was, like I said, a paper 1 question paper, November 2024, right? So different provinces don't write the same paper, guys. I mean, it would make sense, right? So this is just an example paper, all right? So because my grade 8s here in the Eastern Cape have already written, all right, this is the paper that they wrote, okay? All right, that does not mean you'll be writing the same paper, but as per the structure of paper 1, the fact that the paper 1 is 60 marks, it's 1 hour 30 minutes, and the fact that the topics in paper 1 for grade 8 are the ones that have been stipulated and even been told by your teacher, that's one thing that basically would make things a bit similar and common. So if it happens perchance that your paper is like this, then great. But if it doesn't, then it doesn't, okay? And therefore, what I cover in this paper today, all right, is not going to be everything that may appear in your own paper. This is just an example paper, right? It's an example, guys. Please take note of what I'm saying. It's an example, all right? All right, so here we are. This paper began out with a multiple choice, all right, and usually this is a nice way to get students a bit relaxed so that they can get into the groove of things. But don't take your multiple choice questions for granted. Okay, so the first question says, please select the correct answer from the given options. All right, write only the correct letter next to the number, for example, 1.1. All right, and then you write the letter E. So here what they did is that for each choice, choose one correct statement, you had 3 options, A, B, or C, and then they provided space. So what was nice with this paper is that they actually allowed the students to write on the paper itself. So they were not asked in any way to actually to write on a, I guess you could say, on a lined page such as this, okay? So there was no stress about that. But you know what? One of the things that I would really encourage is that even if in a question paper you are just, required to answer on the paper itself, I would recommend having a page where you can do your rough work. Okay, it's very, very important so that you don't just circle answers and take that for granted. So here we go. 1.1 says, choose one correct statement. Okay, the square root of 16 is less than -4. B, a quarter squared is equal to 0.8. C, 39 is a composite number. All right. So which one would you say is the answer here? A, B, or C? And remember, when you write the letter, guys. You don't write, okay? Because I noticed, for instance, when I was busy marking my learners, that some of the learners, they make things so complicated. If they say B is the correct answer, well, then they write out a quarter squared is equal to 0.8 in this space provided. We don't do that, please. Just simply write the letter. One of the ways that we want to check as you answer your question papers is, are you following the instructions? Okay. All right. So I see there, my good friend Kat says C, and he has a question mark, which means Kat is not confident about what he's saying. All right. Okay, so let's look at the square root of 16. The square root of 16, I mean, you could simply just take your calculator and check this thing. So you type in square root of 16 if you don't know it off by heart. Square root of 16 is equal to 4. So is it less than -4? Definitely not. No ways, Jose. So the A is out. A quarter squared, you could do the same thing. Punch this into your calculator, square it and check. Do you get 0.8? So this here, definitely when you punch in your calculator, you don't get it. So B and A are out. Let's look at option C. 39 is a composite number. Now let's look at the theory. What is a composite number? A composite number is a number that has more than 2 factors. Are we together? A composite number is a number that has more than 2 factors. So if you look at 39, the number itself, what are the factors of 39? Factors of 39 are, you have 1, okay, and obviously 1 goes into 39. How many times? 39 times. 2. 2 is not a factor of 39. What about the number 3? 3 goes into 39. How many times? 13 times. So already you guys can see that, hey, the factors of 39, they are more than 2 factors of 39. Therefore, the third statement, 39 is a composite number. That is the option that is very much correct. A and B are incorrect. And how we were able to find that out is that we took the square root of 16, put in the calculator, we got 4. Less than -4, not even close. A quarter squared is equal to 0.8. Is it equal to 0.8? Definitely not. So Kat, you are right. The option here that is correct is C. So please don't just select options for the sake of selecting options. Practically in your head, go through each option and then see if it is actually the right option to select. This is 1 mark, guys, and I'm very confident as a learner that I got that 1 mark because I know my theory and my concepts, okay, around numbers. Let's move on to the next question. Identify a prime factor of 28. Okay, now very important, prime. Okay, what is a prime number? A prime number is a number that only has 2 factors. What are the prime numbers that we know? Okay, prime numbers between 1 and 10, we have 2, we have 3, we have 5, we have 7. Okay, those are prime numbers. But what is a factor? A factor is a number that fits in exactly into another number without leaving a remainder. So if we look at these options, A, B, C, 7, is it a factor of 28? Yes, it is. Is it a prime number? Yes, it is. 14, is it a factor of 28? Does 14 fit into 28? Yes. Is 14 a prime number? No. Okay, so B is out. C, is it a factor of 28? Does 4 fit into 28? Yes. How many times? 7 times. But is 4 a prime number? No. So therefore B and C are out. Our option, Omatla, you are very much correct. CWZA, remember, okay, we write down the letter, not the actual answer. So A is a representation of the correct option. 7 is definitely a prime factor of 28 because 7 goes in exactly into 28 4 times. So it's a factor. But is it a prime number? Yes, 7 is a prime number. So do you see how I am thinking as I select my option? This is not me just circling answers or writing down. Okay, and please, that's another thing here. They did not say I must circle the right option. You must write down the correct option here. Okay, so please always follow the instruction as per what you are told. Now, I'm 100% sure that my answer is correct, right, as I go along. And I mean, I don't even have to come back and check because I know I selected with caution and I applied my understanding, okay, which is very important. Tato, this is grade 8, specifically, grade 8, paper 1. Okay, this is a paper that was written in the Eastern Cape this year. Okay, so this is not just a past paper. This is a recent paper written by the grade 8s in Nelson Mandela District. So 1.3, the decimal fraction of 1/8 is, guys, A, 0.125, B, 1.80, C, 0.18. Ntabi says A, all right? And please, like I said, this is a multiple choice, guys. You just take 1/8, you slot it into your calculator, all right? And you say 1/8 equal, you press SD, in your scientific calculator and it will give you the right option, guys. Okay, the right option. So let's do that. Take your scientific calculator and say 1 over 8, or in other words 1 divided by 8. You press equal, and then on a scientific calculator, if you want the expression of 1 over 8 as a decimal, you say you press that button SD. What do you guys get? Do you get 0.125, which is A? Do you get B, which is 1.80? Do you get C, which is 0.18? Now I see people are saying B, 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 B. All right. A few people are actually identifying the right answer. And my question, what I'm asking myself in my head, when you guys are actually saying B, all right, or you're saying C, what are you applying in order to get your answer? All right. That's my question to you. Okay. Because we have people here that are answering in various ways. And what I'm saying to you is that to simplify this and not make it complicated, all you need to do is take that 1 over 8, all right, take your calculator, press 1 divided by 8, then you say equal. You'll see the fraction 1 over 8 still in your scientific calculator. Then after that, what you simply do is you press that button SD. It should give you the decimal, all right, which is very, very important, okay. Also, those who are like, but sir, we learn things a bit differently. What you guys should know by now is that 1 over 8, if you want to get this to become either 10, 100, or 1,000, obviously we can't multiply 8 by something to get it to be 10. We can't multiply by something to get 8 to be 100, but we can multiply 8 by something to get it to be 1,000. And we multiply by what? We multiply by so we multiply the denominator by 125. Sorry about that. But what we do at the top, we do at the bottom, we do at the top. So if you multiply 125, 8, all right, you'll actually get 1,000. Okay. 5 times 8 is 40. 8 times 2 is 16. 16, 20. 8 times 1, that's 1,000. Okay, so you multiply by 1,000, you get 1,000 in the denominator. You multiply 1 by 25, you get 125. And then obviously we can convert this 125 over 1,000 into decimal. That just means we move, if we're dividing by 1,000, we're moving the decimal how many times to the left? 125, we're moving to 1, 2, 3. So we have 0.125. So our answer is 0.125 if we were to do things manually. But guys, please do remember that you can just simply take this, put it into your calculator, press the say equal, press SD, and you will get the right option. B is not, it's not B, guys. 1 over 8 is not 1.80, and I don't understand why some people are insisting that is the case. It is not C. 1 over 8 is not equal to 0.18. So what I'm saying is that to make life very easy, this is a multiple choice question. It's only 1 mark, guys, and you don't want to be spending more than a minute doing this multiple choice question. What you want to do is you want to just get the accurate answer, and the way you do that is that you take the 1 over 8, you say equal, and then you press SD in your scientific calculator. It will give you the right option. So our right option is A, all right? And I know straightforward that that is the right answer. Let's move on. The value of minus 5, the whole thing squared, plus the cube root of 64. So once again, we can utilize our calculator here. Modibadi, you are saying you don't understand. The decimal fraction. Remember, decimal fraction of 1 over 8 is, that's what they're asking, right? So what you want to do is you want to get this answer as quickly as possible without breaking a sweat, spending less than a minute answering that question. So what I'm saying is you take this 1 over 8 as the fraction, you take your calculator, you punch in 1 over 8, okay? Let me just grab my calculator quickly. So hopefully all of us have this beautiful scientific calculator. Casio, it's the way to go. It's the recommended calculator, okay? So if I have my on button there, I have pressed my fraction, I have 1 over, I press my 8 there, I say equal. You see the 1 over 8 appears after pressing the equal sign. Then I go to this beautiful button, SD, and there it is. I get that answer from my calculator, 0.125. So my option I know is going to have to be A. And I move on. Guys, I spent less than a minute answering that question. Because where there's questions where I need to invest a lot of time, then I need to invest a lot of time on those questions. But I can't be spending too much time answering the multiple choice. But I want to get accuracy, right? Yeah. Okay, then 1.4. The value of minus 5, the whole thing squared, plus the cube root of 64 is. Okay, so same thing here. Since this is a multiple choice question, okay, what I want to do is get the quickest answer in the quickest way possible. So you just go to your calculator. If you guys are people that are allowed to actually use your calculators, okay, I know certain schools, they don't allow it. So you say minus 5, the whole thing squared. And then you add what? The cube root. So the cube root, you say shift, you get the cube root often, get 64, you say equal. And there it is. You get the answer. It's 29. All right, so you come back here. The option, is it A? Is it B? Is it C? And obviously here, the value of minus 5, the whole thing squared, plus the cube root of 64 is actually equal to B. All right, yeah. And I know it's 100% correct. It's accurate. Okay. Please understand that if this had been a question where it was a standalone question and they are saying simplify the question and it's not a multiple choice, remember you would have to show your steps if it was not a multiple choice question. Let's say they had said simplify and this was like a question that was a standalone and you had minus 5, the whole thing squared, plus the cube root of 64. Different story if it was a simplified question, it was not a multiple choice. You need to show all your steps, right? So when you apply minus 5, if you apply the square to the minus, any even exponent applied to a negative sign means we get a positive answer. Then 5 squared is actually equal to 25. So you would actually go through the trouble and say 25 plus the cube root of 64. So the cube root of 64 is equal to what? It's equal to 4. All right, you would get marks for actually writing down this. And then after that, 25 plus 4 is equal to 29. So I hope you guys understand that if this was a simplified question, just a standalone question asked in one of the questions, then we would actually answer it and show our steps. But seeing as though it's a multiple choice question, guys, all you need to do, like I said, is go and punch this into your calculator and get the answer so that you can be in the position of selecting the right option quickly and then move on to the next question. Do I know I got all these marks? Yes, I do. Because everything I did here is accurate. It's 100% on point. Okay, let's move on to the next question. Choose the correct answer for the following expression. And here's the expression. Minus 3x to the power 4 all raised to the power 0. Okay, now what do we know about this? This to the power 0, all right, is outside the bracket. And inside the bracket, we have minus 3, we have x, we have to the power 4. We have the sign, it's negative. We have 3, the coefficient. We have x, the variable, to the power 4. And what is the relationship between the negative sign, the coefficient, and x? These are all multiplied to each other. And everything inside the bracket is raised to the power 0. So what's minus 3x to the power 4 to the power 0? What is anything raised to the power 0, excepting that it's 0? Anything raised to the power 0 is equal to, let's look at the option. Is it 12x to the power 4? Is it B, 1? Is it C, minus 3x to the power 4? Right? So it seems like we have a resounding answer of B, because our bases here inside the bracket, all of them raised to the power 0, give us 1, the answer. We know this from the law of exponents, that anything raised to the power 0 is equal to 1, excepting it's not 0. Okay, now I want to ask this question just for the benefit of people that are in this live. Let's say I had minus 3 to the power 0. This is grade 8. Minus 3 to the power 0. What's the answer, guys? I want to ask this question. What's minus 3 to the power 0? Anyone care to answer? What's minus 3 to the power 0? Isipile says 1. Past question paper says 1. Ntabi says 1. Ashley Siabonga says 1. So we have a lot more people that say 1. Okay, hold it. Guys, minus 3 to the power 0 is actually equal to negative 1. It is not positive 1, but it is negative 1. Okay, I hope you guys can appreciate me saying this. Why do we say minus 3 to the power 0 is equal to negative 1? It's because this to the power 0 only applies to the numerical value and not its sign. Okay, now usually when I talk to my learners, I always say there's a sign, which means S, and there's the N, which is the number. So you must always check, is your exponent hovering above the number and its sign? Okay, or is it hovering above just the number? Let's look at this. What's minus 3? Okay, let me just rewrite this. What's minus 3 to the power 0 inside the bracket? The to the power 0 minus 3 everything to the power 0 is equal to what? So Albert says 1, SM says 1, Deity says 1. And yes, guys, minus 3 to the power 0 is equal to positive 1. Okay, Matabang, it's not 3, it's 1. So there's a difference between minus 3 to the power 0, where the exponent is raised simply to the number, okay, and the difference between minus 3 everything raised to the power 0. Okay, I hope we are very clear about that. We know that there's this law that says anything raised to the power 0 is 1, right? That's a law of exponents. It's a definition in one of the laws of the exponents. Then here, minus 3 to the power 0. This to the power 0 is raised to the numerical value, not to the sign. So the sign still stays the same, but then the 3, which is the numerical value, is actually 1. So that's why the answer is minus 1 here. Look at this one. Minus 3 to the power 0. We have a bracket around the number and its sign. So when we apply 0, which people, in actual fact, 0 is an even number. So if we apply this 0, any even number applied to a even exponent applied to a negative sign leads to a positive answer. And then 3 to the power 0 obviously is 1. So that's why we have a positive 1 here. Okay, so that's something we all need to be very clear about, okay, when it comes to this base raised to the power 0. We must check, where is the 0 exponent applying to? Is it applying to the sign and its number, or is that applying to its number alone? Okay, so I'm just going to leave that there so that you guys can actually allow that to stew. Okay, let's move on to the next question. Which one of the following options is the correct simplification of x to the power 3 plus x to the power 3? Okay, so after I've recorded and done recording this particular session, I'm going to upload it onto my YouTube channel. And if you guys want to know what's the YouTube channel, you go onto the TikTok page, the main page, MathsIsAGame. There is there a icon, the YouTube icon. You can click on that, it will go to the YouTube channel. Okay, so what is the correct simplification of x to the power 3 plus x to the power 3? This tends to get a lot of students, and it's simply because a lot of students do not understand how we add like terms. People, please, I saw this as I was marking the papers for my kids now, that we confuse the rule that is there when we add like terms. So first and foremost, you guys can see these are like terms, right? What is the variable? It's x. What makes the variables like terms? It's because they both have the same exponent. Okay, so it's not just variables that make terms alike, or it's not just the letters of the alphabet that makes the terms alike. It's also the fact that because the variables or the letters are the same, they also have the same exponent. So what is the rule that applies with addition of like terms? When we add like terms or subtract like terms, we always keep the variable and its exponent the same. and then we add and subtract the coefficients. Now, some of you may be like, what is a coefficient? A coefficient is the number that's next to the variable. It's everything around that particular variable's term. All right. So what's the coefficient of x cubed? It's 1. What's the coefficient of this x cubed? It's 1. So what did I say is the rule of addition and subtraction of like terms? We keep the variable and its exponent. So in other words, the variable and its exponent will be a part of the answer. Then we add and subtract the coefficients. So what is the coefficient of x cubed? It's 1. What's the coefficient of this x cubed? It's 1. So what's the addition of the coefficients? 1 plus 1. That gives us a beautiful coefficient of 2. So the answer is 2x cubed. Please, grade 8s and 9s, if you are here, listen to me very well. You guys are butchering this a lot. When you add like terms, I don't know why it is that some of you will say the answer is x to the power 6. Or some of you will say the answer is 2x to the power 6. It's wrong, okay? We do not add the exponents when we are adding like terms. No. When we are adding like terms, we keep the variable and its exponent as it is, and then we add the coefficients, or we subtract the coefficients. Please, people. Okay? All right. So hopefully that is clear for all of us. All right. So the answer here is actually C, 2x to the power 3. All right. Yeah. When do we add exponents? Let's say it was x to the power 3 times x to the power 3. Now, there's a different rule that applies when we are multiplying variables, all right, that are the same. Doesn't matter whether the exponents are the same or not. But the rule is when we are multiplying, right, what do? We actually keep the base, the variable, and we add the exponents. So the answer here would be x to the power 6. All right. So we multiply sign, number, letter. So in other words, the sign of x cubed and x cubed are positive. Positive times a positive is a positive. Okay. Then the number, 1 times 1 is 1. Then the letter, x to the power 3 times x to the power 3 is actually equal to x to the power 3 plus 3. The only time we do this is when we are multiplying bases that are the same. We keep the base, we add the exponents for multiplication. But when you are adding like terms, and people, please take note, like terms means the variable and its exponent are the same. When we are adding like terms, we keep the variable and its exponent. Then we add the coefficients. There's 1 here, there's 1 here, so 1 plus 1 is 2x to the power 3. So I feel like I've actually over battered that point. So hopefully it's clear for all of us. All right, I'm gonna move on to the next. So I know my C is right. I know some people thought the answer was something else, but guys, we need to clarify and have clarity in our minds about this. We can't hop around a misconception for addition of like terms for too long when you're in grade 8, because if you have a misunderstanding of this, it will affect you in grade 8, it will affect you in grade 9, it will affect your maths in grade 10. Then you'll ask yourselves a lot of questions like, why am I not getting this maths right? Okay, so let's get this right. 1.7, 4,15 times 10 to the power 6 is the scientific notation for which value? Okay, 4,15 times 10 to the power 6. So what favor do we do to ourselves here? Okay, Bexy is asking, what if they were not the same base? What if they were not the same base? Remember, if they are not the same base, let's say x plus y. X plus y, the variables, the bases are not the same if you are adding them. So x plus y is equal to x plus y. We do not add or subtract unlike terms. These are unlike terms. Okay. What about the multiplication? X times y. Okay. X times y. Remember, multiplication, what does it do to different bases, it combines those bases. So x times y is actually equal to xy. Okay. What about this? X cubed plus x squared. Question is, okay, we are adding terms here. Do we add are these like terms? X cubed plus x squared, are these like terms? No, they are not, because x cubed and x squared, they are unlike terms. Why? Because their exponents are not the same, guys. So these are unlike terms. So our answer for x cubed plus x squared, the answer would be x cubed plus x squared. We cannot add and subtract unlike terms. So these are unlike. But some of you are probably screaming in your hearts and you're like saying, but sir, aren't the variables the same? Yes, they are, but the exponents make it such that the terms are different. We do not add unlike terms. These are unlike terms. All right. And really and truly, if we get that these are unlike terms, then we are safe. We are sorted, guys, for days. All right. These are unlike terms. Okay. So we only add like terms, but we cannot add unlike terms. All right. And the principle is just there. All right. What if it was multiplication? Obviously, multiplication. Here, right, we have a law of exponents that says if the bases are the same and we are multiplying, we keep the base, then we add the exponent. So our answer would be x to the power 5. People, please understand this as opposed to that. This is addition. These are unlike terms. We cannot add unlike terms. So we have to leave that as it is. Here we have multiplication. And yes, these are unlike terms if you were to say, are they like or unlike? But because there's a law that says when you are multiplying same bases, you keep the base, you add the exponents. That's why you are finding us actually adding the exponents. Please, guys, if you guys can just master this for once, it would make me very happy. Like, really, it would. Like, yeah. These are the little things that actually distinguish a learner that gets a 70% as opposed to a learner that will get 80% consistently. All right. Yeah. And then past question papers, thank you for that. If it was division, okay. All right. Okay. And remember, this is just me chipping in some things right here. So if we are dividing, but the bases are the same, the exponents are different, then what we do is that we keep the base, and then this one top base, this one bottom base. So we say 3 minus 2, which gives us x to the power 1, which can be just simply written as x. So division of same bases, you subtract the exponents. Thank you so much for that clarity, past question paper. I like the fact that there's people here that are really helping out in being able to clarify some of the concepts in the comment section. Nadia, nonsense. I cannot have someone in my life saying such nonsense. You are not going to fail. Okay? Please do not say that, because if you say it and you believe it, it's probably going to be it. No one can convince you otherwise. All right, let's move on. 4,15 times 10 to the power 6 is a scientific notation for which value? So we have 4,15 times 10 to the power 6. This times 10 to the power 6 simply means if I was to write down 4,15 and then times 10 to the power 6, move your decimal 6 times to the right. 1, 2, 3, 4, 5, 6. Right? I usually say these are little pouches where I can put eggs in there. So what I'll do is I'll put the little pouches, right? And basically that means if I remove the decimal, it's 415,000. How many zeros after 415? 4 of them. So if you look at this, 415, 4 zeros, A, B, 4,15, Z, C, You can also put this in your calculator, of course, and the calculator will do a phenomenal job of actually making sure that it serves you very well. All right. 4,15 times 10 to the power beautiful 6, right? And you can just say equal, and there it is. Okay. If you don't want to waste a lot of time, you just put that into your calculator and say equal. It will give it to you. Okay. Yeah. And when it doesn't give it to you, you just simply, like I said, just move the decimal. Do the moving of the decimal. Create your pouches. Remember, times 10 to the power 6, if it's positive, we move to the right. If it was a negative value, we'd move to the left. Okay? Yes, this is grade 8 paper 1. Someone indicated to me that they're writing that next week, so I'm just going over the paper that the grade 8s wrote in Nelson Mandela District, just as a way of helping that person to have the concepts around paper 1 in their minds and hearts. Given the geometric pattern, now here it is, geometric pattern, not linear, but geometric. Remember, a geometric pattern is that kind of pattern that has a constant ratio, not a constant difference, but a ratio. In other words, it will be 1 times something that will give you 5, 5 times a consistent value that will give you 25, and so it goes in that pattern. So it's asking here, given the geometric pattern 1, 5, 25, which number will be next? 1, 5, 25. If you look at this geometric pattern, some of you may not even register that, oh, geometric means we are multiplying a certain number to get the next number. So because of that, some of you will say 5 minus 1. Now 5 minus 1, you can see, will give you 4. 25 minus 5 does not give you 4 as well. So this is not a pattern that has a constant difference. We are not going up by 5. We are not adding 5 to the previous number to get the next number. Please, people, here in this particular pattern, because we are told it's geometric, we have a constant ratio. We're multiplying a certain number each time to get the next number. Does that make sense? So to say that the answer, and we'll see which number will be next. A, 30, B, 125, C, 100. CR for life, you are very much correct. We multiply 5 to the previous term to get the next term. Okay, we multiply 5 to the previous CR, not to the next term. We multiply 5 to the previous term to get the next term. Okay, so is it A? No, because if you're gonna register this as constant difference, you need to be consistent everywhere. If you're saying it's addition of 5, is 1 plus 5 equal to 5? No, guys. No. Okay? Please, guys. So, yes, it's B. It has to be B. All right? So, we are multiplying the previous term by 5 to get the next. All right? Okay? So, therefore, it can't be A. C is out. It has to be B. So, please be thoughtful when you answer your multiple choice questions. Don't just answer and circle and write options. It's not C. It's not C, Jonathan. Okay? Okay, remember, like I said, the geometric pattern. Okay, if we just want to quickly check this out, remember, there are patterns that have a constant difference. There are patterns that have a constant ratio. And please do check your pattern. Is it one that has a constant difference, or is it one that has a constant ratio? So, for instance, if you want to explore this, thank you for the rose, guys. Thank you for the rose, RDK. So, if you come here and you say 5 minus 1, you get a 4, right? So, there's a difference of 4, okay, between 1 and 5. But if you go and say 25 minus 5, do you still get 4? No, you get 20, guys. So if you are getting 4 and 20 as your difference, that means there's no constant difference. This is not a linear pattern. So therefore, you cannot apply the rule, okay, of what you would do with a linear pattern. This is another type of pattern. It's called a geometric pattern. A geometric pattern is a pattern that has a constant ratio. All right, meaning there's a certain number you are going to be multiplying, whether it's a number or a fraction, that you are multiplying by consistently to get the next term. And what is that particular number? So you come here, if it's a geometric, you say T2 divided by T1. So what's 5 divided by 1? Okay, you get 5, right? So that means there's a constant ratio of 5. You go to 25. Let's just confirm that there is a constant ratio, really. We take term 3, 25, and we divide it by term 2. 25 divided by 5. What do we get? We get 5. So that means there's really a constant ratio. How do I get my next number? I'm going to take that 25 and times by 5. And what do I get? 125. So that's why our option is B. It is not A, it's not C, but it is B. Does that make sense, guys? I hope it does. All right, let's move on to number 1.9. A vehicle drives at a constant speed of 120 kilometers per hour. What distance will be covered in 2 hours? I repeat. A vehicle drives at a constant speed of 120 kilometers per hour. What distance will be covered in 2 hours? A, 120 kilometers. B, 60 kilometers. C, 240 kilometers. So those who are hopping in the live and they like, can you help me with grade 9 maths paper 1, grade 9 maths paper 2, can you help me with grade 8 maths paper 2? After I'm done with this live grade 8 paper 1, I'll be transitioning into grade 8 paper 2. And then after that transition into grade 9 paper 1. Then after that transition into grade 9 paper 2. But I'll definitely be having a bit of breaks in between. So I'll do this one and finish it. Do grade 8 paper 2 after a bit of a break. Do grade 9 paper 1. Do grade 9 paper 2. Okay, just an example paper. Okay, and remember, this is not meaning that the paper will come out the way that you see this example paper being done. Okay, all right. Okay, so a vehicle drives at a constant speed of 120 kilometers per hour. What distance will be covered in 2 hours? So there's a constant speed of 120 kilometers per hour. Okay, that means constant speed, right? I'm sure you guys learned about this beautiful D, as it says, DST. All right, when it comes to rate, okay, distance is equal to speed times time. D is equal to S and T, S times T, because S and T are next to each other. S, which is speed, is equal to D over T. And then last but not least, T is equal to D over S. And I cannot really say what time. Why? Because if I say time, then basically, because I'm doing explanations as I go through the paper. All right. So I don't know. You're just going to have to come back and forth and just check where I'm at, right? So yeah. So please, I can't specify, because if I specify and then it just happens that I drag on, the time goes on a bit longer, then I'm going to have to accommodate that. Okay. So I can't really say time at the moment. Okay. So these are the formulas. Thank you, RD. As you can see the formulas here. D is equal to S times T, S is equal to D over T, and T is equal to, you hide T, D over S. Now here, what are we required to find? What do we have first and foremost? We have distance. What distance will be covered in 2 hours? We have time. What are we required to calculate? Distance. So if we are required to calculate distance, we are going to use our formula D is equal to S times T. We know distance, we just put it into our calculator. The speed is 120. The time is 2. We put it into our calculator. We get a beautiful answer of 240 kilometers per hour. So our option that we are going to be choosing here is definitely C. Definitely. And guys, you know what? Sorry, I forgot to put in here that answer A. You know what? Already I know those marks. I've got them. Okay. 9 beautiful marks so far. And I am going for my last question that has to do with the multiple choice. 1.10. It's grade 8, guys. Like I said, I'll do grade 8 paper 1. After that, I'll do grade 8 paper 2. Or maybe I should just do grade 8 paper 1 and then follow it with grade 9 paper 1. Maybe I should just do that. Grade 8 paper 1 followed by grade 9 paper 1. Just so that I'm actually in the same string of thought when it comes to the papers. Yeah. No, I'm glad. Beautiful. TJ, that's beautiful. Pretty sure I got 85% thanks to you. Oh, yes, neat. Oh, man. Okay, that's actually good. That's really encouraging. TJ, I'm glad. So 1.10, the following algebraic expression is arranged in ascending order. The following algebraic expression is arranged in ascending order. Please take note the word ascending. What does that mean? It means ascending means from small to big, or from low to high. But what are we looking at if we are looking at an expression and we want to check ascending order? We are looking at the exponents. Please, people, we're looking at the exponents. So predominantly for 1, 2, 3, 4 terms, we have the x variable, and then we have a constant term. Okay, but look at this. 4, now here, 3 is actually, if we were to write down the 3 with the variable exponent, we'd write down 3 as being 3x to the power 0. I hope that makes sense, guys. Okay, so look at this. This is like me having a expression of x to the power 4 plus 3x to the power 0 minus 2x to the power, look at the x, the exponent 1 is what features there, minus 3x to the power 2. Do I see the variables? All right. With the 3, I decided to just put in the x to the power 0 so that you can see what is the condition of the exponents. Are we moving from low, as ascending would suggest, to high? Look at this. 4, 0, 1, 2. No order here. 4, 0, 1, 2. So A is out. Let's look at B. I'm going to rewrite B with the variable. So 3 would be 3x to the power 0 minus 2x to the power 1 minus 3x to the power 2 plus x to the power 4. So let's look at this. What did they want? They wanted me to arrange in ascending order. Is this ascending? 0, 1, 2, 4. Seems like we are moving from small here all the way to big, I would say. 0, 1, 2, 4. Do you see how I actually made the constant term and made the variable x to the power 0 feature so that I can see, is it ascending or not? So yes, what are we checking for when we are looking at this ascending nature? We are looking at the exponents. So yes, we are moving from 0 to 1 to 2 to 4. This is ascending. Let's look at the last one. This is 4. This is 2. This is 1. And obviously this would be x to the power 0, which would mean it's 0. So this is not ascending. This is descending. Are we together? All right. So what is the following algebraic expression is arranged in ascending order. So which one is arranged in ascending order? It is definitely B. No doubt. Smack bang. It's B. Yes, it is a game. It is a game, Ali Asali. Definitely, it's a game all the way. You learn the rules. You play it long enough. It's so sweet and nice and easy, and you go to Chow Town with maths. Yeah, so this is grade 8 and 9. All right, let's go to question 2, number. So multiple choice, just a word again with multiple choice. Let's make sure when we do the multiple choice questions where a calculator can be used to get the answer quickly, let's do that, guys. Let's not waste time and stay in questions longer than we should. Okay, yeah. So after this grade 8 paper 1, I'll do grade 9 paper 1, okay? And then in the order after that, I'll do grade 8 paper 2 after that, and then I'll do grade 9 paper 2. So I'll do the paper 1s for each grade, and then I'll do the paper 2s for each grade in that order, okay? Question 2, number. Study the following numbers and write them next to the correct description. Guys, we need to know our numbers. So look at this. Even prime numbers. Even prime numbers. Cat, the grade 8 paper 2 from last year is already posted onto my MathsIsAGame main page, the paper and its memo. So you can spend some time and do the paper from last year, and then you can utilize the memo to check yourself. Time yourself, sit down in a quiet space. When you feel confident that you've covered the content, sit down in a quiet space, time yourself 1 hour, 30 minutes, write that paper. Then after that, you go to the slide for the memo, you utilize that and you mark yourself. If you have questions, you can send me an inbox message on the TikTok and then just let me know what questions you have, and then I can help clarify those. Okay, so they are on the main page. You can access them. I think I've written the topics for each question paper very well. Okay. Study the following numbers and write them next to the correct description. Show us page 1.1 to 1.5. Page 1.1 to 1.5. You mean show you the question paper from 1.1. This was what we've done already, guys, okay? Yeah, I will not be going back to these questions, but these are the questions that were 1.1 to 1.4, 1.1 to 1.4 multiple choice, all right? Okay, and then last but not least, these are the questions for 1.5 to 1.9. I will be posting the paper up on the page after I'm done, because this is this year's 2024 grade 8 paper that was written in the Nelson Mandela district. Okay, let's go on. You just want answers. Lebza, you are funny. Study the following numbers and write them next to the correct description. So let's look at the numbers. -3, 8, pi, 1 over 27, 2, and 0.5. The first question is saying they want the even prime numbers. So this number must be even, and we know our even numbers are 0, 2, 4, 6, 8, 10, 12, and so it goes. But it must also be a prime number, this even number. Are we together? So -3 is not even, 8 is even, but it's not a prime number. Pi, not even. Not even. 1 over 27, not. 2 is an even number, but is it a prime number? Yes, it is. 0.5, even number? No. So our answer, the only even prime number is 2. And we write that option, guys, that is relevant to the description. There's no other option that is relevant to the description even prime number. Cat, 1 is not a prime number. You write that down somewhere, or I don't know, maybe you can write that on your forehead for the 2 days before you write the paper. 1 is not a prime number. Remember, a prime number is a number that has 2 factors, and it's usually 1 and itself. So basically, 1 is not a prime number, does not qualify as such, okay? Okay, the cube of a third. Please understand, the cube of a third. So a third is this. A cube of a third is 1 over 3 to the power 3. Now, obviously, what you can do, okay, is you can apply that to the power 3 to both the numerator and the denominator. And then what's 1 cubed? It's 1. What's 3 cubed? It's 27. So our answer is 1 over 27. I repeat, the cube, what does a cube mean? It means this to the power 3. Of a what? Of a third. That means of a third in its entirety. I put it in brackets. If I apply the cube to the numerator and the denominator, I get 1 over 27. So smack bang, our options here, 1 over 27. So it's 1 over 27. I would write 1 over 27. Because here they're saying study the following numbers and write them next to the correct description. So this is something I would do as rough work on the side. Hence I'm saying, if you are given a paper and the paper is the place where you write your answers, please ask the examiner for a rough paperwork, like a rough paper, so that you can actually, explore some of your options before you write your answers, okay? So you would obviously write 1 over 27, okay? Then last but not least, 2 times a quarter. 2 times a quarter. This is what it means. 2 times a quarter. And then you can actually obviously work this out. What's 2 times a quarter? 2 times a quarter, you could even write it down. After writing this down, you can punch it into your calculator. 2 times a quarter is a half. All right, you get 1 over 2. But you know that 1 over 2 expressed as a decimal is actually equal to 0.5. Are we together? So interpreting what this means and making it so that it is actually an expression you can write down. 2 times a quarter simply means 2 times 1 over 4, which is, when we simplify it, we get a half. But a half in decimal form is actually equal to 0.5. And what's beautiful is that you see this calculator that you have, you can do this. 2 times a quarter. And you say equal. You want the decimal, you press SD, you get 0.5. There's the answer. And that's one option. There's no other option that qualifies as 2 times a quarter. Okay? And please answer the question that is relevant, please. Don't answer questions that are not. Okay, let's move on. 3.1, word sums. Why is it so easy? Guys, this paper was the way it was, right? Yeah. I underscored 49 out of 65 in his mathematics test, and I am in no way saying that this is how your papers will be. I'm not saying that. This is just an example. Please don't get relaxed here. If you guys have been given material in your respective schools to go and practice a certain paper a certain way, please go ahead and do it, okay? I underscored 49 out of 65 in his mathematics test 1 and 33 out of 50 in his test 2. The question is, calculate in which test he scored the highest percentage. So let's go through this again. I underscored 49 out of 65 in his mathematics test 1. Okay. But the cube of a third is 8. How? Guys, how is the cube of a third 8? Okay, I see Percy K saying the cube of a third. Okay. Please, people, ne? Let's, yeah. Like I said, these are some of the things that can really destroy if we misinterpret them. Okay. Okay. This is what a cube, the cube of a third. No, guys, the cube of a third. 1 over 3. A third is 1 over 3. Cube is 1 over 3 to the power 3. Okay, please, people, eh? Yeah, otherwise, if we misconception, problem. So I underscored 49. I underscored 49 out of 65. Charlotte is killing me here, forgetting everything. No, Charlotte, you need to get another mindset here. Okay, please. I underscored 49 out of 65 in his mathematics test and 33 out of 50 in test 2. All right. Calculate in which test he scored the highest percentage, right? So, guys, whenever you write a test, right, say this test was out of 65. So 49 out of 65. Hopefully we all know that whenever we want to calculate the percentage for our respective tests that we write, we say 49 over 65 and then we times that by 100%. Okay. So you setting this up affords you a mark equal to, and you say, they said here, round your answer to two decimal places. So we can do that. 49 over 65 times 100. Punch that into our calculator. And I like the fact that Andrew Z already says 75,38. Now let's just check very quickly that that does line up. So 49 divided by a beautiful 765. Then we times that by 100. Gives us a beautiful 980 over 13. We press SD, we get 75,3846, and so it goes. But 2 decimal places means we cut off where 38 is. We look at the third number and we ask ourselves, this number, what does it say to 8? If it's less than 5, then this number stays the same. If it is 5 and more, this number goes up by 1. So obviously this is a number that is less than 5, so therefore this number stays the same. So that's why our answer is 75,38%. Okay, so that's the mark percentage for the first test. That's test 1. Let's look at test 2. Test 2, 33 out of 50. Times that by 100. Okay, I'm sure you guys see when you type this into your calculator, you get 66%. Okay, so let's just go back again. We first take the mark out of the total mark. That's 49 over 65. Then we times that by 100%. Remember that the total percent you can get for a test is 100%. So that's why we multiply by the total. We take the mark that he got over the total mark, and we times it by the percentage. So we get this 75,38%. Then here, test 2, we take the test 2 mark that he got out of the total mark, we times it by 100. Then we get 66% from the calculator. So these are the 2 tests. He got 75,38% for test 1. He got 66% for test 2. The question that they ask is, calculate in which test he scored the highest percentage. So you need to then have a conclusion. Therefore, Ayanda scored the highest percentage in what? In test 1. Of course, you would have like more neat handwriting than I do, because you are so neat and amazing. So you would say Ayanda scored the highest percentage in test 1. Okay, and that is the percentage mark he got, 75,38%. Okay, so someone who's marking your beautiful work, yes, please put percent, because that is supposed to be there. 1 mark for the setup, 2nd mark for your answer, another mark for the setup, fourth mark for your answer, and then lastly a fifth mark for your conclusion, because they want to see if you'll be able to write down the conclusion, calculate in which test. So your answer needs to reveal in which test he scored the highest percentage. Okay, hopefully that makes sense. Let's move right along. 3.2. Hopefully we are all good. I can move. Am I allowed to? 3.2. Matthew and Kevin received 2,500 as a gift from their uncle. I'm sure some of you are anticipating a lot of Christmas gifts this coming December, right? Some of you are probably having their birthdays come up. You're expecting a lot of gifts and stuff. I think I am as well, because my birthday is like in this month on the 15th. So I'm expecting a lot of gifts. Matthew and Kevin received 2,500 as a gift from their uncle, which must be divided in the ratio 2:3. So Kevin is going to receive 2 parts of the gift. Matthew is going to receive 2 parts of the gift. And then Kevin is going to receive 3 parts of the gift. Okay, you're writing after your birthday. That's funny. I undergot level 6 in maths. He did, didn't he? Oh yeah, he did. For test 1, that is. But for test 2, what level did he get? He got level 5, right? Okay, so Matthew and Kevin received, I'm going to repeat, Matthew and Kevin received 2,500 as a gift from their uncle, which must be divided in the ratio 2:3. Calculate how much money Kevin will receive. All right, so here we have a direct question where we are asking how much did Kevin receive. That's all we really care about. How much did Kevin receive? So with these questions, we first have to check out what are the total number of parts that we have as per the ratio we are given. We add the ratio to get the total number of parts. 2 parts plus 3 parts gives us 5 parts. Then what are we interested in? It says calculate how much money Kevin will receive. We don't really care about Matthew. We want to know how much will Kevin receive. Kevin's part is the 3 parts, right? It's not the 2 parts, it's the 3 parts. So we're going to take the 3 parts that Kevin has, divided by the total number of parts, which is 5. Then we are going to times it by the gift, the total gift amount, which is 2,500. Okay, and then utilize the beautiful, amazing calculator so that we can find out how much money Kevin will receive. So let's do this. 3 over the beautiful 5. Okay, and then we're going to times it by the 2,500. And then we're going to check how much money. It seems like our good friend Kevin is only going to get out of the 2.5. Kevin is getting 1.5. Yeah, does that make sense? Prime numbers, Ronaldo, are numbers that only have 2 factors, 1 and itself. In other words, if we look at the numbers between 1 and 10, is 1 a prime number? No. 1 is not a prime number because 1 doesn't have 2 factors. 1 only has a factor of 1. And basically, those are not 2 numbers. Let's move on. 2. Does 2 have 2 factors? Yes. 2 has the factor 1 and 2. These are the numbers that go into 2 completely and leave no remainder. Okay? Yeah. So I'm thinking the reason why I'm being asked a random question on prime numbers is because that person is probably, not understanding what prime numbers are. 3 is a prime number. Is 4 a prime number? Definitely no. 5. Is 5 a prime number? Yes. 5 is a prime number because the only factors of 5 are 1 and 5. There are no other numbers that fit in exactly into 5 and leave no remainder besides 1 and 5. So the factors of 5 are 1 and 5. So these are the prime numbers. 1, 2, 3 is also a prime number because its factors are 1 and 3. Right? So prime numbers are simply numbers that only have 2 factors. The opposite of prime numbers are composite numbers. Composite numbers are numbers that have more than 2 factors. Are we together? More than 2. Okay, so guys, how much money did our beautiful Kevin receive? Kevin received 1.5. Okay, and it makes sense because if Kevin is receiving 3 parts of the money, then he's supposed to be receiving more money than Matthew. All right, now imagine if these were siblings. I don't know if they would really be happy about this divide of gifts, because if you're a parent and you all of a sudden divide the gift, in 2 parts Matthew, 3 parts Kevin, Matthew will have a problem with Kevin. And Matthew will be like, these parents, they love me less. So you can actually deduce just from the amount that Kevin got, how much money Matthew will be getting. Because if it's the total is 2.5 and this Kevin gets 1.5, what's left? 1,000 rand. So Matthew will be getting 1,000 rand. Yes, this is grade 8. Yes, this is grade 8, guys. Moving right along. Sorry about that. Just had to quickly close the door. All right. Yes, definitely. You can do that, Ratile. Ratile, that's basically the same thing. Ratile is asking, can you take the 2.5 divided? Look, guys. Can you take the 2.5 divided by 5? Yes. And then times it by 3? Yes. Yes, it's the same thing. Okay. If you guys are looking at this and you're like, that's not how my teacher did it, but I still get the same answer. It just means the method is different, but it is right. Are we together? You are right. 3-mark allocation, adding the parts, setting up the equation, answer. In the bag, phakathi inside. Okay, phakathi inside. Let's move. Question 4, number patterns. Here we are. Term 1, consider the number pattern. Term 1, term 2, term 3. Answer the questions that follow. Term 1, term 2, term 3. What is happening? Number of blocks. Term 1, how many blocks do we have? Do we have 5? Yes. 1, 2, 3, 4, 5. SM, what do you want me to tell and iphinde now? What's happening? What time? What else do you want me to pinda? This Matthew and Kevin scenario. So Matthew and Kevin received 2.5 as a gift from their uncle, which must be divided. And this is the thing. When you divide a certain quantity into a certain ratio, this is the approach. When you're dividing a certain quantity into a certain ratio, in the ratio 2:3, calculate how much money Kevin will receive. So what you do, like I said, is you will add the two values of the ratio so that you can get the total number of parts. Then because we want to know how much money Kevin received, if we look at the ratio, 2 parts represents what Matthew will receive. 3 parts will represent what Kevin will receive. In the order, Matthew and Kevin, 2:3, 2 parts belongs to Matthew, 3 parts belong to Kevin. You add the parts, you get the total number of parts. Which part represents Kevin's parts? It's 3 parts. So you take the 3 parts, you divide it by the total number of parts, and then you times by 2.5. You get this amount of money for Kevin. It's the same thing as saying 2.5 divided by 5 and then timesing by 3. Same thing. Okay, moving right along. Number patterns. So this is term 1, this is term 2, this is term 3. If we look at the diagram, this is a figure that we have 1, 2, 3, 4, 5. We have 5 blocks for term 1. Makes sense. Term 2, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks indeed. Makes sense. For term 3, we have 1, 2, 3, 4, 8, 9, 10, 11. 11 blocks for term 3. We need to fill in. It says here, answer the questions that follow. Complete this table. Woo! Go and complete it, guys. What was sad for me is that my learners, some of them, they just did not complete the table. They left this blank. 3 marks gone. Sad. No, grade 8. This is grade 8. Okay. Now, if the number of blocks is 23, the question is, what is the term number? Now, some people, they rushed and they put 4 here. No, guys. No. Let's be careful here. Be very careful. Proceed at a very slow pace. You can see here that there's a constant difference of 3. 8, 5 plus 3 gives you 8. 8 plus 3 gives you 11. All right. If we continue on, all right, I would just do this. Okay. So I'm going to add 3. If I add 3 again, I'm going to get 14. But that's 14 for term 4. If I add 3 again, I'm going to get 17. That's for term 5. If I add 3 again, I'm going to get 20. That's for term 6. If I add 3 again, I'm going to get 23, which is for term 7. So I write 7 there. And then last but not least, they are asking me for term 9, all right, how many blocks should there be? Remember, we were at term 7. Now we add 3. We are going to get 26. That's for term 8. We add 3. We get 29. That's for term 9. So I'm going to write 29. Okay. So that's for me to complete the table, please. Completing the table, all right, is just simply going through what I see as my constant differences. I look at the term number and check and verify. For term 3, there's 11, definitely. Which term has 23 blocks? And then you just simply use your constant difference to be able to do that, okay? So that you can populate the missing spaces with the relevant number. So I'm just going to look at it again, just for those who may have just missed it a bit here. So term 1, there's 5 blocks. I could verify there's 5 blocks indeed. Term 2, when I count the number of blocks, there's 8 blocks. That makes sense. Term 3, there's how many blocks? 1, 2, there's 4 here, plus 4 is 8, plus 3 is 11. So there's 11 blocks. Then you come here, 23 blocks. Which term has 23 blocks? So remember, the last I had was 11. I know there were 11 blocks for term 3. And the constant difference is 8. So I'm adding 3 every time. So I'm going to go here and add 3. In my head, I am still thinking, okay, 11 represented term 3. Plus 3 is term 4. That's 14. Term 4 is 14. Plus 3. Term 5 is 17. Plus 3. Term 6 is 20. Plus 3. Term 7 is 23. 23 blocks is term 7. I write 7. Then next one. 9. The 9th term. Remember, I was here. Term 7 had 23 blocks. Plus 3. 26. That represents term 8. Plus 3. 29. That represents term 9. Okay? That's 29 blocks with term 9. I've completed the table. So I'm simply using my constant difference to be able to find my term number and, okay, the value of the term. Rams, you'll have to go to my YouTube channel because I'm going to be uploading this there so that you can re-listen. Okay, just interest of time, guys. Write the rule in words. So if I write the rule in words, because that's what they're saying, write the rule in words. What am I going to say? Add 3 to the previous term to get the next term. Guys, that's just it. Okay, add 3. Okay, and if you want, you can just say add 3. Right? I know some people are like, you wrote the 3 as a number, why don't you write the rule in words? So there we have it, guys. Add 3 to the previous term to get the next term. Or you can just say you add 3 to each term. That's fine as well, to get the next term. Okay, but if you said add 3 as a number, that's fine, doesn't really matter. What they want here is for you to just write down the rule, you know, as a statement, which is what basically this means. Let's move in here. Determine the general term. Some people don't understand that general term means Tn. It also means nth term. Guys, these are synonymous words. They could say determine the general formula or the rule. If they say this to you, okay, that's basically them saying they want Tn, all right, expressed in algebraic form. Okay, so I know there's people that have been saying, please do the Tn thing. Okay, and this is it. Okay, how do I get Tn? All right, so basically I'm going to suggest something. You write Tn is equal to dn plus c. All right, I'm just really and truly, people, if you feel like you've done this in a certain way in your class, please stick to that way. All right, I'm not saying that you should change everything now and do it this way. Tn is equal to dn plus c. What does the d stand for? The d stands for constant difference. Okay, so my d, which I'm sure you guys saw from the table above, d is equal to t2 minus t1, but you also need to verify if T3 minus T2 still gives you the same value, because constant difference, the difference needs to be constant for all terms. Okay, so 8 minus 5, what's 8 minus 5? 8 minus 5 is 3, guys. It's 3. All right, moving right along, what's 11 minus 8? You still get a 3. So that means we have the constant difference, it's 3. So I go to my rule, Tn is equal to Dn plus C. In the place of D, I write 3. All right, N stands for position, plus C. Now what I need to now get is I need to get the value of C. Okay, so Tn is the general term. It's the rule, basically. It's the rule expressed in algebraic expression. The algebraic expression of the rule is what we refer to as Tn. It's the general rule for a given sequence. All right, that's Tn. It's the, that's Tn. But if you want to speak specifically, as it says, Roblox, I like what you've said, Tn is term number, yes. All right. So for instance, when we substitute in the place of n1, then we get term number 1. Term number 1. If we substitute 2 in the place of n, then it's term number 2. If we substitute term T3, then it's term number 3. So I like what Roblox said there, that Tn represents the term number. Okay. So Tn is equal to Dn plus C. D, constant difference. N, the position of a particular term. All right. So the value of that term that we get after substituting its number. Okay. Now, so Tn is equal to 3n plus C. How did you get the 3? We took T2 and we subtracted T1. Okay. Then we want to get the value of C. So how do we get the value of C? We can go to a particular value of a term. Okay, let's just say we're going to take the value of the term 8. So in the place of Tn, because Tn is the value of the term 8, what is the position of 8? Okay, it is 2. So we substitute in the place of n2 plus C. That's how we're going to get our value for C here. So 8 is equal to what's 3 times 2? It's 6 plus C. Then when we are solving for an unknown, take the 6 over. We say 8 minus 6 is equal to C. So C is equal to what's 8 minus 6? It's 2. Therefore, our C value is 2. So what's Tn? Tn is equal to 3n plus 2. This is the general term of this sequence of blocks. Okay, this is the general term of this sequence of blocks. Okay, so what we can do, and I'm going to repeat this, when we want the general term, it just means we want to find Tn, or the nth term. So in other words, for a linear sequence, Tn is equal to Dn plus C. D is our constant difference. Okay, how do we calculate it? For a term or a linear pattern that has constant differences, okay, we have T2 minus T1, we check, we get 3. If we take T3 minus T2, we still get this 3. T3 is 11 minus 8. 11 minus 8 is equal to 3 still. Then what we do is that we say Tn is equal to 3n plus C. The only thing left to do is to calculate our C value. So we can go and take any value of any term and its position. Okay, I'm just going to repeat this and take another value of the term so that you guys can see that I can calculate the value of C using any value of the term. So let's just say I take the value of the term 11. That means in the place of Tn, I'm going to substitute 11. Then I'm going to substitute the position of 11. N is 3 plus C. Then I'm going to go ahead and find the value of C. What's 3 times 3? It's 9 plus C. Then I transpose the 9. It becomes negative 9 on the other side. So what's 11 minus 9? That gives me a beautiful answer of 2. So therefore C is equal to 2. So Tn is equal to 3n plus 2. Okay. Okay, no, you are not at all, Anna. You could use term 1, you could use term 2, as long as when you substitute the value of the term, you substitute its position. Remember, the value of the term 8, its position is 2. All right, and I still get C is equal to 2. If I take the value of term 3, which is 11, Then I substitute its position. I still get a C value of what? Of 2. So our rule remains as Tn is equal to 3n plus 2, no matter which value of which term I decide to substitute. All right. All right, guys, I'm going to move right along. Okay. Move right along. Move right along. In this question paper, we actually were given then a 4.4, which says use the above table to plot the line graph of the first 3 terms in the space below. So the learners here were asked to actually use the table that they were given for your sequence to plot a line graph of the first 3 terms in the space below. So just back to the table here. The table has term 1, which is 5, term 2, which is 8, and term 3, which is 11. Term 1, 5, term 2, 8, term 3, 11. So there we have it. This is the graph paper that they were given. This is term 1, term 2, term 3. Now the y-axis has the number of dots. So for each term, they were supposed to identify the number of dots graphically here. So you have 0, 0, 2, 4, 6, and so it goes. And so that means the in-betweens are 1, 3, 5, 7, and so it goes. So for term 1, the value of the term, the number of dots that we have, or blocks, is how many? We have 5. So if you come here, this is 0, 1, 2, 3, 4, 5. So we go to the corresponding point. This is term 1, 5 blocks. Term 2, 8 blocks. So we go to 8. Where's 8? It's here. If we go to where term 1 is, term 2, sorry, is, that's here. So term 2, 8 blocks. Then we go to term 3, 11. Term 3, 11 blocks. So we go to the y-axis. We locate 11. It's between 10 and 12. That's here. And then we go to where the term 3 is, which is term 3, sorry. That's here, sorry. Okay, that's a mistake there. Shouldn't have gone there. Term 3, that's 11. All right. And then the learners, all they were supposed to then do after that was to just take the ruler and just connect these dots and draw that straight line. Because they were asked to use the above table to plot a line graph. Line graph. Line simply means they take that provided graph paper with the labeled x and y axis, and then what they do is they just connect the dots using their ruler. Okay, and this is definitely called a Cartesian plane, just revealing this part. No, they just draw the line because they said use the above table to plot a line graph of the first 3 terms. So they were supposed to just show the line graph showing the first 3 terms. So for term 1, this is where it starts. Term 2, then term 3. So they just draw a line that connects those 3 dots. And that was that for them. Okay. I will post the paper. Don't worry. Just calm down. Kolofelo is in a rush. Okay, let's go. Question 5 was algebra. Given the expression 7 plus brackets 8 minus x, the whole thing squared, plus 6x squared minus 5x cubed, plus 9x over 2 minus 3x to the power 4. First question, how many terms are there in the expression? Now I need you guys to respond. How many terms? Kat says 6. Everyone here will pass in Jesus' name. Tavonga, definitely, thank you very much. Maipasia says 7. Okay, that definitely means there's a misconception there with Mapasia. 7. M says 7. Guys, I'm going to explain this. And it would be nice to know the one who said 7. Okay, and all my kids, even my learners, some of them said 4, some said 3, some said 2. I'm like thinking to myself, this is something I never taught, guys. Okay, let's first establish what separates terms. What separates terms? Okay, if we can know what separates us, then we will be sure to know what not to involve, in our lives. Because we don't want to be separated, we want to be combined and become one. So what separates terms? Plus or minus sign. Thank you very much. Guys, what separates terms is a plus and a minus sign. What combines terms? Okay, because when we know what separates us, we'll definitely know what combines us. Okay, so what separates us is a plus and a minus sign. What combines terms? Bonolo says brackets. Beautiful. I love that. I love that you said that. Brackets combine. Multiply and divide also combine terms. Okay, bracket, fraction. Very good. Thank you. Past question papers. Past question papers. Probably a teacher here coming to peep in. Okay, let's see here. So let's go, guys. Here we are. 7 plus separate. Bracket means this becomes one term. Are you with me? Inside the bracket, there's two terms, but this is one term. Why? Because the bracket combines the terms to become one. So we can count, if we are counting here, if we are doing a stock take, this is one term. Plus separates. This is two terms. Okay? This is the second term in its entirety. 8 minus x squared is 1 because the bracket is around 8 minus x squared. Plus 6x squared. This is the third term. Minus 5x cubed. This is the fourth term. Plus 9x over 2. This is a fraction. This is the fifth term. It's the fifth term. 9x over 2. Minus 3x4. This is the sixth term. So those who said the terms in the expression, there are 6, you guys were spot on. It means you guys understand the concept behind the terms, what separates them, what combines them. Okay. That's good. That's good. Well, keep it up, past question papers. You're doing a phenomenal job. And I'm sure you probably get messages galore. Guys, please follow past question papers. If that is a person that's posting past question papers, some of the papers that I have here may not be papers that are available, and past question papers most probably is in the game, has been in the game for much longer than I have. I've just kind of like come in the past 2 weeks. So please, guys, definitely make it a point you follow past question papers. Let's just do this very quickly. I appreciate you. Are you a sir or ma'am? Yeah. I think let's do this as well. Okay. I think let's do this. Let me follow you as well. Past question papers. Yeah. So please follow past question papers for past question papers. Access to that, all grades. I think that would be good. Okay. Write down the coefficient of x, 5.1.2. Write down the coefficient of x. So let's go here. If we look at the terms that are here, the only term that has a coefficient of x, and please take note of the x, there's no exponent, all right, that is more than 1. This is the exponent 1, all right. Now, the only term that has x and the exponent 1 is the fifth term. This has exponent 4, so that's not the term they're talking about. This is not the term because it's to the power 3. This is not the term. This is not the term at all, and this is not the term. So it's the fifth term that they're talking about. We'll write down the coefficient of x. So what is the coefficient of x there? Roblox here, no. Past question papers, yes. Okay, it's 9 over 2, people. Please take note, and I'm going to say this now. I know some people tend to think of this definition that says the coefficient is the number before the variable. But please take note that the coefficient, it would seem to also suggest that it is actually everything that is combined with the x. And I'm going to say that everything combined with the x. Since we have identified, write down the coefficient of x, it means we're actually taking the x not into consideration. Okay, we're only considering this term because it is the term that has x. But the minute we write the coefficient, it's like we're actually saying hide the x away. What do you have that is combined to the x? Guys, you can see it's 9 over 2. It's not 9, it's 9 over 2. So your answer, the coefficient of x, is 9 over 2. Who's following me here? Who's with me here? I'm going to repeat this. The coefficient of x is everything combined with the identified variable. Okay? Not that variable. So it's like you say goodbye to the x, and then what do you have? 9 over 2. So that's the coefficient of x. Okay. Right, moving right along. I'm glad it's me. Please, guys, let's try and really be kind. I don't want you guys saying a buckload of things about other teachers and stuff. Please, let's avoid that by all means. Teachers really do their best in their classes. Funny thing is, with my own students, they would vilify me and mock me, despite the fact that some of you may say you are understanding here in this platform if they were listening to someone else. A prophet has no honor amongst his own people. That's the tendency. So okay, so let's try and avoid such in the comment section, please. 5.1.3, give the value of the constant term. What's the constant term? The constant term is the term that has no variable. Okay, so you can see, Moss, which term is this one? Okay, all of you are answering correctly here. So it's 7. You're spot on. Okay, you're spot on. Sorry, I just wrote in the wrong place. The value of the constant term is 7. Okay, yeah. All the other terms exhibit a variable. Some of you may have said it's 8, but you can't say it's 8. Remember, 8 minus x squared is one term inside the bracket. Okay, so therefore it's not 8. 8 is not alone. It's one term there. So please, people, it can't be 8. It is only 7. Okay, yeah. Then last but not least, write down the degree of this expression. By degree of the expression, I like what past question paper just said there. It helped us out in the comment section. Degree of the expression simply means the highest exponent in the expression. Thank you so much. Yeah, you're phenomenal. You're phenomenal, truly. So yes, the variable with the highest exponent there, simply put, you can see, guys, it has to be. When you write down the degree is 4. You can write down the number 4, or you can say the degree. Yeah, well, okay, you can say it is 4, or you can say the degree is 4. All right. Okay, and then last but not least, 5.1.5, calculate the value of the expression if x is equal to 2. So what you do there is, as it says, the value of the expression if x is equal to 2. So that means everywhere where there's x in your expression, all right, you need to substitute the value of 2 using your brackets. And that's very important. Okay, so you're going to write down the expression. And then everywhere where there's an x, you're going to write 2, which is very important. Inside brackets, you're going to provide brackets, and you're going to write down the value of 2. Okay. So they need to see that you actually understand what they mean by that. Okay. So you can see, guys, what I've done here is I've actually written the number 2 inside brackets. Okay, please put it in brackets. Then you can go ahead. Okay, this is 8. 2 squared is 4, so that's 8 minus 4 plus that's 6. 2 squared is 4 plus 5, that's 8, plus 9 times 2 is 18 over 2, because 9 times 2 is 18. And then here you have 2 to the power 4, which is 3 times 16. All right. And then, I mean, it's just application getting of board mass, if you know what I mean. So 8 minus 2 squared is 4, you see. Remove the bracket. 6 times 2, 2 to the power 2, because bad mass, please, bad mass applies. Okay, you can't multiply this 6 and this 2 before applying the exponent to the 2 first, because brackets, then exponents, okay? Then division, multiplication, addition, and subtraction in that order. Then 7 plus, now 8 minus 4, you have 4 there, plus 6 times 4 is 24, plus 8 times 5, which is 40. 18 divided by 2, you have 9, and then minus 3 times 16, you have 48, negative 48. And then what you can do is you can punch all of this into your calculator. You'll get a beautiful answer of whatever answer you're supposed to have gotten. Oh, I wrote plus here. Okay, my error, my mistake. Sorry, guys. That's supposed to be minus here. Sorry, a bit of a mistake there. That's supposed to be minus 40. Okay, please forgive me for my errors there. Okay, right. So 7 plus, that was 8 minus 2 squared, which was 8 minus 4, which is positive 4. 6 plus 6, 2 times 2 to the power 2, which is 4. 6 times 4 is 24. That works out. That was a minus, guys, not a plus, as I had done initially, so I'm sorry about that. Minus 5, 2 to the power 3 is 8. 5 times 8, that's 40. Okay, and then 9 times 2 is 18. 18 divided by 2 is 9. Minus 3 times 6, which is 18, so that's minus 48. Then you just put this there. You can calculate very nicely. 7 plus 4 is 11, plus 24, minus 40, plus 9, minus 48. You get a beautiful answer of negative 44. Okay, that's 3 beautiful marks, guys. Substitution alone gets you a mark, guys. Substitution alone, okay, gets you a mark. 2 to the power 3 is 8, ne? Yeah, 2 to the power 3 is 8. Remember, 2 to the power 3 means this. 2 times 2 times 2. I know some people, they say 2 to the power 3, 2, 4, 6. Oof, don't do that, please, guys. 2 to the power 3 means 2 times 2, which is 4. And then 4 times 2, which is equal to a wonderful 8. Let's not make the misconception. It's like some people say 3 to the power 2 is also 6, but it's not. 3 to the power 2 means 3 times 3. What's 3 times 3? It's 9. Okay? Let's not get things... okay? Let's not get things mixed up there. Alright? So usually the substitution is 1 mark. Then obviously you getting the numerical values and then obviously your answer. Okay? Yeah, because what they want to see basically is they want to see that you can actually move from this substitution, applying what you know about board mass and bed mass, all right, brackets, exponents, division, multiplication, addition, and subtraction, and then being able to utilize your addition and subtraction board mass, being able to get your final answer. They want to see how fluent and how easily you can go along and do those, all right? Okay, then 5.2.1, simplify the following expression. Add this to that. So in other words, 2x squared minus 4x plus 6, okay, plus 3x squared plus 9x minus 1. Now some of you are like probably wondering what's happening here. I took this because I need to add this here to something that's already there. And what I do is that my second expression, I put it in brackets deliberately. Okay, the reason why I do that is because you always distribute the sign outside that bracket so that you can be able to then do your addition and subtraction of like terms in the next step. Group your like terms and then add them. Okay, so the statement, you need to interpret it correctly. Add this to that. So addition is commutative. So even if I had written the first expression first and then followed it with the second expression, it would still be fine and correct, because addition, and I repeat, there's a property that says addition is commutative. In other words, when you add numbers, it does not change the value of the answer. So in other words, 1 plus 3 is the same thing as 3 plus 1. Okay, so that's why basically we apply that addition. It doesn't matter in what order. So let's go. Like I said, we write this 2x squared minus 4x plus 6. We remove this bracket. We take the positive. When we distribute the positive, it does not change anything inside the bracket. So I still have 3x squared plus 9x minus 1. Then what I do is I group like terms. So in other words, 2x squared. Who's 2x squared's like term? Who's his friend? His friend is him plus 3x squared. So I bring them together because you bring friends together. Plus 3x squared. Who's minus 4x's friend? Minus 4x's friend is him plus 9x. So I bring them together. Minus 4x plus 9x. Who is 6's friend? 6's friend is -1. So I bring them together. Plus 6 minus 1. When you bring them together, you bring them together with their sign. You might have noticed that when I circled the like terms, when I rectangled the like terms, I rectangle, circle, and triangle them with their signs, because when I bring them together, I need to bring them together with the sign. So what's 2x squared plus 3x squared? Final answer. 2x squared plus 3x squared. Remember, when we add like terms, we keep the variable and its exponent, and then we add or subtract the coefficients. 2 plus 3 gives you 5. Move on to the next like term. Negative 4x plus 9x. We keep the variable and its exponent. Then we add and subtract the coefficient. Now, I know some people, they butcher this. -4 plus 9. So what I usually tell my students to do is that with their calculator, just say -4 plus 9 so that you can be sure about the answer and we don't butcher that answer. So the answer is plus 5x. Then last but not least, what's 6 minus 1? It's plus 5. Guys, that's it. Done and dusted. Finito. All right. I know some people with these types of questions, they will usually do the following: 3x squared plus 9x minus 1, and then they'll say 2x squared minus 4x plus 6. And they kind of do it the way that you used to do it when you were in primary school. All right. So -1 plus 6, then they'll get the 5 there, but it's positive. Then they'll say 9x plus minus 4x, that will give them the 5x, and then they'll say 3x squared plus 2x squared, that will give them the 5x squared. And that's, there you have it. Okay. All right. I hope that makes sense. All right, so that's just another method, another way of doing it. Okay. Why you not add 5x, add exponent to, I don't understand what SM is saying. The common factor. No. Talk show SA. Remember, this is saying simplify the following expression. Okay, this is grade 8. Okay, and a grade 8 learner. All right, we, at the moment with grade 8, they have not done factorization. Factorization only features in the next term, the next year for grade 8, grade 9, not grade 8. Okay, so this is grade 8, and even with your simplification question, you wouldn't factorize this because this is a simplify question. You leave it like this, even if it's in grade 9. 5x squared plus 5x plus 5, that's it. Okay, right. 5.2.2, subtract this from that. So what does that mean? Who do I start with? Do I start with the first expression or the second expression? Subtract this from that. Subtract 10 from 12. Okay? Who starts first? Number 2 starts first. So let's do that. 15m minus 4n plus 2p. Now subtract. Then I put the second expression in brackets deliberately, people. Okay. You might have noticed I did that with the first question as well. You put the second term in brackets. I do that deliberately. Why? Because the negative sign needs to be distributed to all 3 terms. And I repeat that. The negative sign needs to be distributed to all 3 terms before you can add and subtract like terms. So 15m minus 4n plus 2p. You take the negative sign, you distribute it to the all 3 terms. Negative times a positive, negative 12m. Negative times a negative, positive 8n. Negative times a positive, negative 5p. Right? Yo! And some people throw away marks because they don't do that. Then 15m. Now we are going to collect the like terms. 15m and minus 12m. They are the friends that you need to bring together. Minus 4n plus 8n, they are the friends you need to bring together. Plus 2p minus 5p, they are the friends you need to bring together. 15m minus 12m, the sign along with the term, together. Minus 4n plus 8n, with the sign you bring together. And then last but not least, plus 2p minus 5p, you bring them together. Then what's 15n minus 12m? When you are adding and subtracting like terms, you keep the variable and its exponent. You add and subtract the coefficient. What's 15 minus 12? It's 3. Now the like terms. N, so you keep the variable and its exponent. You add and subtract the coefficients. What's minus 4 plus 8? Some of you will not make sure I know. So you take your calculator. Minus 4 plus 8 is equal to, you have positive 4. Plus 4n, it's make sure. Then last but not least, 2p minus 5p, you keep the variable, you add the coefficients. What's 2 minus 5? It's negative 3. But your calculator, so that you can always make sure. Any questions? 3 marks, guys, in the bag consistently. Amen. Hallelujah. 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 And as we do the winding down scenes of the paper, because we are nearing its end, paper 1, grade 8, 2024, paper written in the Nelson Mandela district. If you are in a different district and you are about to write paper 2, then yeah. Then 5 point from paper 1, then this is the place. Jose Mulefe, do you do grade 10? Send me a personalized DM. Then I can arrange a day where I can do grade 8. Today I'm focusing on just grade 8 and 9, but I can definitely do grade 10 and I can do grade 11. But that would need for there to be a large number of people that are showing interest in that. So just send me a message personally on MathsIsAGame in the inbox, a request message, and I'll get back to you. And gather around your friends so that when I do the live, there can be a sizable amount of people that can actually join in and have the opportunity of doing that. Okay. I know, hey, some of us wrote maths paper 1 long time ago, but some of us still yet to write it. Maybe you can share the paper with me in the inbox if you are coming from a different province. I'd really appreciate that so that I can post it for the benefit of many. 3x into 5x plus 8y minus 4. So here we have a monomial, and here inside the brackets, though this is one term because of the bracket, but inside there are how many terms? 3 terms. So we use the distributive law. But please, people, distributive law, DL, when you use your DL, consider SNL. By that I mean sign, not the interesting letters that you guys see when you're about to watch a movie that's inappropriate. I mean S meaning sign, N meaning number, L meaning letter. You distribute considering the sign, number, letter. Okay? So let's do this. 3x times 5x, sign first. Positive times a positive gives us a positive. So sign sorted. Then we move on to the number. 3 times 5, 15. Then we move on to the letter. X times x. When we multiply same bases, we keep the base, we add the exponent. So this is x to the power. We know there's 1 and 1. What's 1 plus 1? That will give us 15x to the power 2. Let's move. Next term. Distribute 3x to 8y. Positive times a positive gives us a positive. 3 times 8 gives us 24. X times y, we combine the letters x and y together. Last but not least, 3x times minus 4. Sign, number, letter. Positive times a negative, negative. 3 times 4, 12. X next door to the 12. So our final answer is 15x squared, 24xy minus 12. Beautiful x. That's it. 3 marks in the bag. That was a nice, beautiful meal. 5.2.4. Okay, so whenever you have a monomial by a trinomial, you use the distributive law and you apply sign, number, letter as you distribute this one guy to all his partners or all his friends, or as you share all the Christmas gifts to everyone inside the bracket, everyone in the home. A proud dad will be doing that in his household during Christmas time. He'll become the Santa and he'll start distributing his love to all the members of his family, one by one. So here 5.2.4, let's go. 10x cubed minus 5x squared plus 20. How many terms in the numerator? 3 terms. How many terms in the denominator? 1 term. This becomes 1 term because it's a fraction, but we acknowledge that there's 3 and 1. So what do we do whenever we have a situation like this? For grade 8, we split the 3 terms respectively to the denominator by doing the following. 10x cubed, we divide by that 1 term. Minus 5x squared, we divide by that 1 term. 20, we divide by that 1 term, whilst retaining the sign negative and positive. All right. Next, so we separate them. Next, we divide and we use S and L again. In other words, take note of the sign, number, letter as you divide. So let's go. Positive divided by positive is positive. 10 divided by 5 is 5. X to the power 3 has no corresponding variable in the denominator, so it sticks in the numerator next to the 5 combined. Next, negative divided by positive is negative. 5 divided by 5 is 1. X squared in the numerator stays x squared in the numerator. It has no shared variable. 20 divided by 5 is 4. That is our answer. 10, 20 divided by 5 is 5. I love it. I love it. That means you guys are not sleeping then. 10 divided by 5 is definitely not 5, but it is actually 2. So that was a genuine error made by a genuine sir. So I acknowledge my errors because that was a genuine error that I shouldn't have made. Okay. So this SNL thing has to do with when we are using the distributive law for multiplication, all right, in the sense that we are multiplying. If you are using the distribution law, then you need to consider your multiplication. As you multiply, you need to consider the sign. What does a positive times a positive give me? Then number. What does the number, when I multiply them, give me? The letter. If the variables are the same when I multiply, what laws must I remember? You know, that's what I mean. Okay. Also, when you are dividing, you need to also consider the sign, the number, and the letter. Okay. Okay. Does that make sense? Okay. Yeah. I hope that makes perfect sense. Okay. And yes, past question papers. Okay. This is basically how we do when we make silly mistakes like that. Yeah, well, we lose it. But I'm happy. The fact that most of you actually commented in the comment section and said, no, sir, 10 divided by 5, you are wrong there. That shows that you guys are actually quite good in your maths, and you are very vigilant, and you are very much in tune with what's happening. My hope is that when you guys write your own papers, what you do is that after you are done writing, all right, and you write in time and you finish in time, you can go back to the question paper. Don't just close your paper and sit there and watch everybody else in the exam room, okay? Or have this nice feeling that I'm done, I'm finished. Go back to your paper and go through each response that you gave and check if you were accurate in all of your responses. You know, someone like me would definitely, even if I made that error, after I'm done with the paper, I'd definitely go back to each question and check, did I answer correctly? Was my division accurate? So that I can be able to pick up on errors like this. And I definitely would have picked up on it even if I had passed this question and gone on with the rest when I check. But in order to check, you need to be able to finish on time, you know. So I hope that's very much helpful there. Let's go to 5.2.5, negative 2p q cubed to the power 5. So let us look at this. How many terms? One term inside the bracket. One term because of the bracket, but also one term inside the bracket. What's the relationship between negative 2p, negative 2pq, and 3 and to the power 3? What's the relationship between the numerical coefficients and the variables? It's multiply. So there is a law of exponents that basically says whenever you have bases that are multiplied and you have another exponent raised to the respective bases, then what you can do is you can apply that exponent and multiply the exponents, all right, for those respective bases. You can do that. A to the power m m times p. So it's like you distribute the p by multiplication, distribute the p by multiplication. I hope that makes sense. Okay, so please do that, but this only applies when the bases have a relationship of multiply, and it also applies when the bases there's a relationship of divide as well. Then you can distribute the exponent, all right, by multiplication, but only if the relationship between the bases is multiply or divide. It cannot happen, guys, when the relationship between the bases is times. Sorry, let me just, I need to. All right, so let's go. Like I said, we cannot do this where the bases there's addition or subtraction. Distributing the exponent like this, we cannot do that. Okay, so let's always take note of that. So the laws, there are laws behind what we do, right? So then when you apply this to the power 5, here's another thing. Odd exponents do something to negative sign, and that is when we apply add exponent, because we apply S and L whenever we are doing this. When you apply this odd exponent to this negative sign, it stays negative. But if this exponent was even outside our bracket, if this exponent was even, if applying an even exponent to a negative sign changes the negative to a positive. So please, people, okay, a negative sign, if this exponent is even, will lead to a positive answer. But a odd exponent outside the bracket applied to a negative sign will keep the sign negative. And this is very important for you to note. So an even exponent to a negative sign will lead to a positive answer, but an odd exponent to a negative sign will lead to a negative sign. So let's apply this. Odd exponent applied to the negative sign stays negative. Then we have 2 to the power. There's a 1 here. 1 times 5 gives us 5. P to the power. There's a 1 there. 1 times 5 also gives us 5. Q to the power 3. That's 3 times 5. I hope you guys are good. Then we have negative 2 to the power 5. If we use our calculator, we get 32. P to the power 5. Q to the power 15. Okay. So very, very important what we just learned here. Okay. Very, very important. Okay. Now moving right along. This question, right, is half x is equal to 6. Now, I had a bit of a problem with this particular question, and the reason why is because, you know, any learner who's looking at this, okay, I had a problem with the notation, whoever was setting the paper, because 1 over 2x is equal to 6. This x appears as if it's in the denominator with the 2 alone. All right, so learners could have interpreted this to mean this, meaning 1 over 2x. Some learners could have interpreted this to mean a half x is equal to 6. Now, personally, I thought that if someone is marking the paper, they would have to consider how the learner interpreted this. So if the learner interpreted this question to mean this, then the person who's marking would have to go along with how the learner interpreted it and check if their algebraic manipulation is correct. Okay, yeah. So anyways, that's just me. Anyways, that's the way the question was phrased, though, okay, meant this: half x is equal to 16. So what do we do whenever the coefficient is known? All right, we divide both sides by the coefficient. Okay, so obviously, since the coefficient is half, we divide both sides by half. If the coefficient is half x, and then the variable is x, and it's next to the coefficient, then what we do when solving an equation is that we divide both sides by the coefficient of the variable. Okay, so if we divide both sides by half here, that means half divided by half leaves us with 1, so we are left with x is equal to. Now, what's 6 divided by half? 6 divided by half is the same thing as 6 times 2, which is actually equal to 12. Okay, so our answer there is x is equal to 12. That's the value of x. X is equal to 12. All right, and that's as pure and as simple as that question is. Okay, let's move on to the next one. 2x minus 7 is equal to 15. So what we do first and foremost is we take this constant term and we transpose the constant term, because there are two terms in the left and one term on the right. So we're going to take the negative 7, transpose it to the other side. Okay. Then that's 2x is equal to, we take the minus 7, 15 plus 7. And remember, guys, there's no magics in math. It's not like we're taking a negative 7 and it changes sign, okay? What we do is that if we want to get rid of this negative 7, we apply something called the additive inverse. So in other words, to get rid of this minus 7, we are going to add 7 on the left. But what we do on the left, we must do on the right. Hence, the answer here, or at least the next step, is 2x is equal to 15 plus 7. Minus 7 plus 7 gets rid of the 7, of the negative 7, and we're left with 2x. Adding 7 on the other side will basically lead us to getting 2x, which is equal to 22. All right, so please, negative 7, when we say we take negative 7 and we take it over to the other side and it changes sign, understand that that comes from the idea of us applying the additive inverse to an equation. Okay, then we have 2x is equal to 22. Now what do we do next? We take the coefficient of x, which is 2, and we divide both sides by the coefficient of x. Okay, and then basically that leads us to an answer. X is equal to, what's 22 divided by 2? That's 11. Okay. Okay, so once again, just to go back, 2x minus 7 is equal to 15. How do we solve for x? We take the negative 7, we transpose it to the other side. 2x is equal to 15 plus 7, which is 15 plus 7 is 22. Okay, then after transposing, we then get 2x is equal to 22, but then to solve for x, we need to have x on the left hand side. We divide both sides by the coefficient of x, which is this number. This number next to x, we divide both sides by it. So if we divide by 2 both sides, we are left with x alone on the left, and then 22 divided by 2 gives us what? 11. Okay, so that's basically solving this particular equation. 2x minus 7 is equal to 15. Yeah, they can't behave. You guys need to take note of your comments. Yeah, well. Right, then 1 minus x is equal to 3 into 1 minus x, which is the last question in this paper. 1 minus x is equal to 3 into 1 minus x. So we have 1 minus x is equal to 3 into 1 minus x. We have to distribute the 3 into 1 minus x so that we can actually get the terms that are supposed to be a result from this distribution, a monomial by a binomial. So once again, a monomial by a binomial, we have to distribute the 3. What's 3 times 1? It's 3. All right. Positive times a positive is positive. Then 3 times 1 is 3. We distribute the 3 to the negative x. Positive times a negative is negative. 3 times the 1, which is a coefficient there, is 3. And then the x next door. Okay. And then last but not least, minus x, which is the variable. We want to get the variables on the left on one side and the numbers on the right on the other side. So negative x, there's a negative 3x. It needs to join the negative x. But then 3x is negative. When we transpose it to the left, it becomes plus 3x. Then we have 3. We take the 1 over to the other side, it becomes negative 1. Okay, then negative x plus 3x. If we are adding like terms, what did I say? We keep the variable. Then we add the coefficients. Negative 1 plus 3 gives us 2x. Okay, then 3 minus 1 gives us 2. Then we want to solve for x. So 2 times x, what we do is we divide both sides by the coefficient, and then we get a nice answer that is equal to 1. Okay. Okay. So guys, that's it. That's the question paper. All of it finished, completed. So this question paper, all right, I'm just going to repeat that last question just for the benefit, the first question for the benefit of those that said they could not really understand what was happening. Guys, here it is. Half x is equal to 6. All right. So here the coefficient of the variable is half. So what do you want to do whenever we solve for x? We want to isolate, leave x alone on the left. But there's someone who is a problem, and that's half. Half needs to go. How do we get rid of the half that's multiplied to x? Okay. We divide both sides by the coefficient of the variable x, which is a half. So I'm going to divide both sides by a half. Does that make sense? But remember, x divided by half is the same thing as writing it like this. X divided by half. But remember, with divide, you can change divide to multiply. And what happens to the second fraction? It becomes 2 over 1. So it's the same thing as 6 times 2. So x is equal to 12. Okay. All right. So I don't know if that makes sense, a bit more sense to those who did not understand in the beginning. Yeah. Yeah, thank you so much, question paper. Question paper is really helping out there. Yeah, so I'll be doing, after being done with this, I was thinking of actually just doing grade 8. Why are we multiplying? Why are we multiplying where? So there's a rule in mathematics that if you have 6 divided, so for instance, we have 6 divided by half, right? We can we change the divide sign to multiply. And then this means that this fraction, we write it in its inverted form. So it's no longer 1 over 2, it's actually 2 over 1. So this is something that in grade 7 and 6, you guys should have done, writing a fraction as its reciprocal. Okay, but this is something that happens whenever we're dealing with division, but then our division of these fractions, okay, we want to express the division as a multiply sign, which means we have to write the second fraction as a reciprocal of the other fraction. And reciprocal just simply means that the denominator becomes the numerator and the numerator becomes the denominator whenever the division sign changes to multiply. And you always do it to the second fraction. You don't do it to the first fraction, but you do it to the second fraction. Okay. And guys, this is basically this question paper. And I have to then obviously bring it to a close here, okay, at this present moment. I am thinking that I will be doing paper 2 for grade 8. So let's just finish grade 8 and then I'll just do another segment of grade 9, paper 1 and paper 2 later on. So let's finish grade 8, but I'm not going to do it now, okay? This is 2024. This is a paper that was written by the grade 8s in the Nelson Mandela district this year, okay, but this is in the Eastern Cape, as you can see, Nelson Mandela district. So it was written recently, okay, and I just went over that, okay. SM, the thing is, I explained this TN thing, you guys. I don't know how much more, okay. Let's just go back just here for you. So 5, 8, 11, 23, and 29. We have how many terms? 1, 2, 3, 4, 5 terms in the sequence. All right. And these 5 terms in the sequence have a constant difference of 3. All right. Yeah. I only do it now because I couldn't do this paper when it was written. It was written, done, and finished, right? So after it's being written, done, and finished, that's when I could do the live. I couldn't exactly do the live before then because it was not available. Okay, and please, people, let's get this correctly. Doing these lives is for the benefit of people for them to just be able to remember some of the concepts that we've done. So I'm just trying to really help people to remember, okay? Yeah. So yeah, that's very important. So I think what I'll do is I'll do a specific video where I'll post this particular question and just TN and how it's done. Okay. But right now I have to bring this live to a close. Okay. So thank you so much for those that joined. Thank you. I think there was someone that actually sent me some roses there, and I really appreciate it. Thank you so much. That's really appreciated. But I'll see you guys for the next segment later on, right? For grade 8 paper 2, I think I'll probably get that started 10 past 11. So let's shoot, guys, for 10 past 11, okay? Because I need to actually just do a few things, and then at 10 past 11. So let's say 11 for 10 past 11. I'll do a grade 8 paper 2, all right? Last year's paper from my district. And then I'll also like go over some concepts that are important where paper 2 is concerned, all right? And maybe if there's questions that people have in the comment section, they can ask those, right? Then after I'm done with the grade 8 paper 2, I'll do grade 9 paper 1 after that, all right? And then after that, I'll do grade 9 paper 2, all right? So you're just going to have to bear with me with the time and so forth, like I said. So I'll do grade 8 paper 2 when we reconvene again at 10 past 11. I'll do grade 8 paper 2. Then after that, I'll do grade 9 paper 1, GEC specifically. GEC, but remember the GEC learners, all right, those who are writing GEC, those who are writing common papers that are not GEC will benefit from actually tuning in to the live for the GEC paper 1. Then I'll do grade 9 paper 2 thereafter, okay? But maybe just at different times, guys, because I need to accommodate the time that I have. That will still be within today. This is still today, guys. This is still today. So at 10 past 11 today, I'll do grade 8 paper 2, and then after I'm done with the grade 8 paper 2, still today I will do grade 9 paper 1, and then still within today after that I'll do grade 9 paper 2, okay? And then grade 7, I'm sorry, unfortunately. I'm sorry specifically because yeah, okay, my focus is on high school grade 8, 9, 10, 11. Okay. Thank you so much as well for joining in, and thank you to all that joined in. Yeah, have a good one so far. And I will be posting this video on my YouTube channel, so you guys can go to this main page, Maths is a Game. You can click onto the YouTube icon. It will send you directly to the YouTube page. It's still new, guys, like, so I don't have much on there, but I'll start uploading some of the videos that we do here. So obviously it will probably be longer than what you want it to be, but for this paper it will cover obviously those certain things, and obviously it will be laced with some of the explanations and some of the comments and maybe some of the disruptions. That's just a bit unfortunate, but yeah, so we'll be doing it like that. Yeah, so like I said, it's grade 8 paper 2 at 10 past 11. After that we'll do grade 9 paper 1, and then after that we'll do grade 9 paper 2. Okay, you're welcome, guys. Thank you so much, and thank you for joining in, and thank you for your time and being here. Cheerios, toodles, goodbye. Shout out to